Okay, I guess it's 12:20. Welcome to this week's HDF Clinic. So yeah, this, as it so happens, there are 5 Tuesdays in October, and on the last Tuesday I get the privilege to answer questions first and foremost, but then also, if there are no questions, choose a topic. So before I jump into a topic, are there any questions for those of you who joined here today? Any questions about anything related to HDF5? No? Okay, then I will jump right in. So today is extra fun for me if others do the work and I sort of can present their work, and this is a good example. In fact, as we will see in a moment, I will actually highlight 2 community projects. And the first one is, this is relatively new. It's a project called PureHDF. And interestingly enough, it is interesting for a variety of reasons. Probably the 2 topmost reasons are, number one, it is an implementation of HDF5 in .NET, in C#, .NET specifically. And what's more important is it does not depend on the HDF5 library, or as people in the .NET framework might call it, unmanaged code. So if you write code in one of the .NET languages, such as C#, F#, VB.NET, and all the rest of it, you have the ability through the pinvoke interface to call unmanaged native code in DLLs. However, of course, you lose a lot of the benefits of the .NET platform in terms of safety and debugging and convenience and all the rest of it. And interfaces like that have existed in many incarnations for a long time. The HDF Group produced one a while ago. I believe it was called HDF.net or HDF5.net or something like that. Then we tried to reduce the amount of code in a language binding like that, or in a platform binding like that, and the so-called pinvoke interface, the platform invoke interface, seemed to be like a good choice. And because then this pinvoke interface pretty much consists out of declarations where you tell .NET something about the entry point in the DLL that you want to call, the type of the arguments, and so forth. So it's, in a way, it's code-free. It's just declarations. And that project exists. It's called HDF pinvoke. However, with .NET, things actually have come a long way. Back when we did HDF pinvoke, for example, it existed for Windows only. So .NET was a platform on Windows only. But since Microsoft has ported, or the community behind .NET has ported the platform so that it can run on Linux and Mac OS as well. And so it is, at this point, it is open source, which it wasn't back when. It is open source. It's a community platform, and yeah, it's a very interesting platform to look at. And so this PureHDF project is an implementation of C#, an implementation of HDF5 in C#. And by implementation, I mean that the author of PureHDF went straight to the, if you look at the HDF5 file format specification, it describes exactly how things are laid out at the bit and byte level in an HDF file. And that's what he did. He looked at the specification, and that's what he implemented in .NET in PureHDF. And of course, he did this because he is someone that is very versed in sort of patterns and idioms that you have in C#. The HDF5 API that you get with PureHDF doesn't look at all or very much like the C API, for example, that you get with the HDF5 library. And so this is the GitHub repository, and there are some examples here, but there's also he has GitHub pages where he has some help. He also, by the way, so I said this is an independent implementation of HDF5 in .NET. It is not the first independent implementation, so to speak, and he lists a few in .NET space, or but there are others. There is, for example, one in Python called Py5, if I remember correctly. There was one in JavaScript called JS5, and there were a few others. However, both Py5 and JS5, for example, and I forgot who borrowed from whom. I forgot if JS5 is based on Py5 or Py5 was based on JS5. I can't remember. But those two actually supported a rather narrow or use case specific subset of the file format specification, whereas PureHDF really aims to support everything that's laid out in the file format specification, not just the earliest version of the specification, but up until the latest version of the specification. Okay, and I thought let's just walk through a few examples, but at the same time, I also want to show you that .NET is actually a very interesting platform, and you can actually, it's very easy to get started. You don't have, if you don't want to, you don't have to install anything locally. All you need is a GitHub account. And so here is my fork. So since this is a public repository, you can create a fork, and then you can do your own thing with PureHDF. So I forked it. And then some of you may have seen this. In GitHub, there is something called code spaces, which you can think of like it resembles a little bit of a Docker container where you can just spin up a machine and then do some development in there. And if there are changes that you want to bring back to your repo, you can just commit them. And if not, you just abandon it, and that's it. So no local installation. I'm here on a Chrome box actually. So the types of applications that I can install are rather limited anyway. So this is a perfect environment for me, and you can actually configure. Since I want to show a multi-threaded example in a moment, I want to beef up that instance a little bit. So I'm going to say here new with options, and I can pick the branch. I created a branch here called HDF Clinic. I made some minor modifications to the project, which I'll point out in a second. Like in other public cloud providers, you can specify a region, but in this case, okay, US East works just fine for me. Since I want to show something with multiple threads, I'm going to go with an 8-core machine and 32 gigs of RAM and a 64 gigabyte sort of kind of storage, probably SSD. And then I just go ahead and say, create a code space, and this sets up your a Docker container, which in and of itself wouldn't be very much, but as you can see already, this gives me a VS Code, a Visual Studio Code interface, and that makes it a lot more interesting to work with. And so this is the project, PureHDF. And what we can do is, I can, for example, here I get a terminal. I can, for example, build the underlying assembly, the PureHDF assembly in particular, but also a few other assemblies. What I can show you also before I build it, well, it actually doesn't matter in which order I do. So here you can, for people who are familiar with the .NET build process, you can say .NET build, and that will just build the assemblies that come with PureHDF, including, you see, there are also compression libraries and things like that. So it's not just PureHDF itself. And that builds, and it's rather quick. So that's all fine. One thing I will point out, and we will see that in a moment, that's where we come to highlighting a second community project. In your GitHub repo, you can create a folder that GitHub Codespaces will recognize as a configuration file. You can create a .dev container folder in double quotes, and in that dev container folder you can put a configuration file called devcontainer.json, and you can use that configuration file to configure, for example, in my particular case here, for example, I would like certain extensions, certain VS Code, Visual Studio Code extensions pre-installed. The two that I want pre-installed is one, and I'll use it in a moment. This is a development that came out of the H5 web visualization tool at ESRF, the European Synchrotron, and they on top of that H5 web visualization tool, they packaged it as a VS Code extension. So this is the extension that I want preloaded, because in a moment we will be using PureHDF to create HDF5 files, and it's actually a good test to say, okay, I created this thing that allegedly is an HDF5 file. Now you could use H5 dump or HDF view to look at that HDF5 file. And if that alleged HDF5 file is really an HDF5 file, then these tools should have no problem whatsoever rendering it. So H5 Web, for example, is built on top of what's called H5 WASM, the WebAssembly, and the WebAssembly uses the native HDF5 library as part of its package. And so this is a good test. In a moment, when we create an HDF5 file, I can then, inside of VS Code here, just double-click that HDF5 file, and that will actually show me a rendering of the content of that HDF5 file, and we'll do that in a moment. Another extension that I'm not going to delve too much into, nowadays you might say, well, don't people use Jupyter notebooks? Yes, absolutely they do, and it probably doesn't come as a surprise that you can run C# code inside of a Jupyter notebook, and the corresponding VS Code extension for that is called .NET Interactive, or I believe nowadays, the name escapes me now. At some point they renamed it, but sort of the .NET Interactive stuck. Oh, I think it's called Polyglot is the VS Code extension. If you, in VS Code, there is this thing here called, this is the extension manager, and you see it's called Polyglot Notebooks. That's what it's called. But since I have in my branch this customization file, whenever I launch a a GitHub code space, these two will be installed automatically, and I could install others. I believe this uses an Ubuntu image by default, but this is another thing you can do in a dev container. You can choose a different flavor of Linux or some other OS if you want. But yeah, okay, so this is about PureHDF, not about code spaces. Okay, so we have an environment, fantastic. And what I did is I created a folder in here that I called Test HDF Clinic, and I created a C# program in here that I will show you in a moment. But before I do that, I want to show you the kind of HDF5 file I would like to create using PureHDF. And here's something, if you go to our documentation that is sort of generated from Doxygen, there is the BNF, the Bacchus-Naur language description of the H5 dump output, the output that you get from H5 dump. And at the bottom of that specification, it has this example here of an HDF5 file in this data definition language, or DDL. And if you look at it, okay, there is the HDF5 file called example.hdf5 or H5. And the root group happens to have an attribute called attr1, and it's of a string type, and the value is string attribute. Then there is a two-dimensional 10 by 10 data set, just 32-bit integers of this nature. Then there is a compound data set. Compound, it has 3 fields, an int, a 32-bit and a 64-bit float, and this is the value. And then there is a group, and in that group there is another data set that happens to be of a committed data type. The committed data type is down here. And then we have this data set dset3 in the root group that is a variable length integer sequence element type, and it has 4 elements, these 4 sequences here. And then, yeah, we do sort of fancy stuff in double quotes with, we have a subgroup in the root group called group 1, and then we link that a second time and call it group 2. So you would have 2 links, group 1 and group 2, but they would point to the same group. So this is a hard link. And we do that here. And then we just add a soft link as link 1. Obviously, this value here would be nonsensical, but for symbolic links, that doesn't matter. So this is my reference, and you don't have to sort of remember it by heart. I'll show you in a moment. But this is sort of, yeah, my go-to example whenever I try a new framework or a new setup. So this is the C# code, and let's just look at it. So in C#, like includes in a C or C++ program, there is if you want to load other modules, there is this using command in C#. So I'm using PureHDF, and then similar to Java, for example, the main function, so to speak, can be wrapped in a class, and in this the class is called program in this case, and then you have this public static void main with potential string arguments, and that's it. And then inside of this main function, I'm just now calling API functions from PureHDF. What I want to point out is, if you remember, I'm just going to sort of flash back here. This is what our example looks in the DDL. And if you sort of squint, this looks like, yeah, either look at it as a glorified S expression where things are just nested. And this type of nesting pattern, if you squint, this is actually exactly what this code looks like. So in C# speak, this would be like an initializer. So you have, I'm declaring a local variable here called file, and I'm creating a new object, H5 file, and then these curly braces, that's sort of an initializer list. And in that initializer list, the things that I want to sort of pass on to that constructor are a comma-separated thing. So I pass on an attribute here, then I put in a data set, then I put in another data set and another data set and so forth. So you see this follows very closely this type of a syntax, which I find very intuitive. And so you can think of this this type of syntax a little bit. The counterpart of this in H5Py would be, for example, a with clause. In H5Py, you can say, for example, with f as h5py.file : and then anything that you nest under this with clause would be sort of in the scope of this with clause. And once all the things are processed in this with clause, Python makes sure that it automatically closes the file, because that local variable would be then out of scope, and it just makes sure that the right things are happening. And this is a little similar, so it's almost like, yeah, with file as PyHDF.h5 file. Okay, cool. So let's look at this. So first thing is, remember, we have an attribute called attr1, and this is going to be a string attribute with the value string attribute. And yeah, okay, so this is C#, everything, every new object is, so to speak, generated with new, with the new operator. Then the syntax for multidimensional arrays is a little different from C or from other languages. So yeah, for one-dimensional array, there would be no comma here. For a two-dimensional array, 1 comma, three-dimensional array, 2 commas, you get it. And then there is an initializer here. So this is just the value of this two-dimensional data set. And then, yeah, it in this initializer list, he has adopted this sort of hash table-like syntax, this key value. So this would be implicitly interpreted as, okay, I'm creating a new data set because I'm supplying a multidimensional array here as value. And by the way, I want to link this in the root group, because the file is also, if you wish, the scope of the root group. I want to associate with the symbolic name dset1, or as link, as we call it in HDF5. I want to link this data set, this two-dimensional array, as data set 1 in the root group. Okay, in a moment I'll execute this. I'll just talk about the next two examples. The next one would be another data set. This time, remember, this was a compound type, a compound data set here that has 3 members, an integer 32-bit float, a 64-bit float. And interestingly enough, in .NET, you can do something. In C, you would typically first define a struct and then construct an array of that struct type, and then basically allocate, or statically or dynamically allocate an array of that struct type, initialize it, and then just write it. In .NET, that's a little simpler. You can have these so-called anonymous types. If you think about Lambda functions as anonymous functions, in C#, in newer versions of C#, you can have this thing called anonymous types. So here I'm telling C# basically, okay, I have a one-dimensional array of something, and then I'm just initializing these 5 elements. And I'm basically, of course, since it's an array, this is an array of a homogeneous element type, I have to make sure that the type that C# will infer from these definitions is consistent. But then, yeah, so I'm saying these are basically records that have 3 fields, A, B, C, and then, of course, to disambiguate 32-bit floating point numbers from double precision floating point numbers, I have this sort of this literal F or D suffix to disambiguate that. And that's it. And I'm going to call this thing dset2. And then likewise, in .NET or in C# specifically, there is the concept of a ragged array. Some people call it ragged or jagged array, where basically you can have an array of arrays, but then the arrays do not have to have the same length for each position or each index. So in this case, the first array, as we saw in the DDL, it's just the array that contains 0. The next one, it's 10, 11. Then it's a 3-element array or 3-element sequence, 20, 21, blah, blah, blah. And that's it. And then again, the C# compiler is smart enough to infer, well, in this case, I'm giving it the type, but PureHDF then sees, okay, this is a ragged array. That means I got to turn this into a one-dimensional data set of a variable length sequence type. So before I continue, the way you would run this in .NET, you would just say .NET run. I mean, you oops. Oh, I'm sorry, I'm in the wrong directory here. So I have to go to test HDF Clinic, and then I can say .NET run. And this just, so this compiles it, but you see it created this file called example.h5. And if I double click that, you see, yeah, I can look at the HDF5 file in Visual Studio Code, and this invoked this H5 web application. And you see, so this is my file called example.h5, and I can click on inspect, and you see the root group has an attribute called attr1, and the value of that string type attribute is a string attribute, and it's scalar. And so that's good. Moving on to dset1, this is our 10 by 10 data set. It's integer, it's 32-bit, it's little endian. Our data set 2 is of a compound type. It has 3 fields, A, B, C, integer, float. So this is float 32, and this is float 64. And here it gives us more detail about the offset and so forth. But if I display this, we can see, so it had 5 elements, and these are the values of the fields. And then we don't really use it here, but H5 Web has the nice property that you can actually, let's see, in this case, it only gives us the option for matrix. I think if we have a one-dimensional data set, like this, you can actually, it offers you, and it's of a compound type. So in this case, dset1 was this integer data set, was scalar, and we can have a heat map or a line plot, or look at the, so to speak, the raw values themselves. So that's nice. Our data set 3, unfortunately, I think this might be a bug in H5 Web in how it deals with variable length data, because if I look at the HDF5 file in a different viewer, HDF view, for example, I actually see the variable length sequence data set, that 1D variable length sequence. So I have to get in touch with the H5 web developers, but it happens. I mean, okay, not a big deal. There are, of course, limitations in PureHDF at the moment. It does not support everything. So if you remember back, okay, we got this, we got the compound data set, then we had this data set here nested in group 1 that is of a committed data type. Well, number one, I think I noted that here in the comments, currently PureHDF does not support committed data types. So the committed data type is usually for, in double quotes, regular data types. The element type of a data set is just stored as part of the metadata of a data set or attribute. However, you have the ability to persist outside of an attribute or data set a data type definition. If it's a complex type, or you just want to put it there for documentation, you want to give it a name, you can do that and actually link it to the group structure of the HDF5 file. However, PureHDF does not support this at the moment. Okay. Another thing that PureHDF does not support at the moment are soft links. So in this BNF example, we had this soft link down here where you can just say, okay, create a link, and then for the destination, just put what would otherwise be a path name in the same HDF5 file for a soft link. PureHDF does not support this at the moment, but that's coming. So nevertheless, I want to show you how to create a subgroup. So if you look at this file here, the scope of this initializer list actually ends down here. So you might say, well, how do I add a subgroup to this? Since I have this local variable file here, what I can do is I can sort of call it in Python hash table style or dictionary style. I can actually use that variable and then assign values to keys. So in this case, I want the subgroup to be to be linked as group 1. And I'm just constructing a new HDF group. And then again, this serves as the initializer list for this new HDF group. And just for the fun of it, I'm just going to put 2 attributes. I'm going to decorate this group with 2 attributes. And then something that's, again, interesting is I'm going to create a compound data set. But what I'm showing here is actually you can also nest compound types. So if you look at an individual record, like this first record here, you can see that it has 1, 2, 3, 4 fields. The difference being that, okay, the first 3 fields, they are all scalars. So it's just, again, our integer, our 32-bit float, our 64-bit float. However, the last field called D is going to be a record that has only 1 field of string type. So if you look at the data type definition of this, you would expect to see a compound type with the 3 scalar fields. And then you would expect that 4th field to again be a compound that has a field of type string. And that is indeed the case. So if I look at this data set here and I look at the definition, you see that this is a compound type that has fields A, B, C, D, and then D again is a compound type that has this single string field. So, so nesting compound types or nesting other types is actually no problem. And then finally, you see here the BNF, this example asks for creating this hard link, meaning we want to create a link called group 2 that points to the same destination as this link called group 1. And yeah, that's just a simple assignment like this, where we say, okay, I want the value of this key, the link in this case, in the root group, because file in this case is overloaded also as root group. And I want that destination to be the same as group 1. And then we just write this to the file called example.h5, and that's exactly what happened here. So cool, that works, and it's easy to try. So if you want to try this for yourself, just as I showed you, create a GitHub code space and so forth. Now, there's one more thing, and then I'm running out of time here, that I want to show you. A very interesting thing that the author of PureHDF did is he actually did a little bit of benchmarking. So you might ask, for example, well, is this, for example, multi-threaded in the context of HDF or the HDF library in particular? People say, well, can I read data with multiple threads? And the answer is no, out of the box. In particular, if you use the multi-threaded or thread-safe build, you are really only locking, protecting library internal structures, and any kind of API, HDF5 API calls, that is, that are issued will actually be serialized. They are never there is never HDF5 library code being executed by different threads concurrently at the same time. However, since this is an independent implementation, the author paid actually attention to threading and thread safety and so forth, and he included a little benchmark here, and I invite you in your own time to look at this. This is a read benchmark where he constructs, I believe, a 1 gigabyte data set, and he constructs, I forgot, 1 megabyte chunks, and he compares just running this, reading all the chunks from this data set sequentially. That's his baseline. Then he uses his multi-threaded implementation to read multiple chunks. I believe he uses 4 or 5 threads, and he then also uses, he supports different file stream implementations. This is another thing that comes with the .NET framework. So you can have, for example, a memory stream, like a memory map file, or you can have a file stream, which is just a regular file stream that's backed by a file in the file system. And he compares the performance of these 3 different scenarios. And I just want to quickly show you that, to show that under the right circumstances, you can actually achieve a pretty good speed up. So remember, this is a container. We have 8 cores, so we're not going to use all of them. And I don't know if there are 8 real cores or sort of just 4 cores with 2 sort of hyperthreads or something like that. But we should get something pretty decent. So this is this PureHDF concurrency benchmark. He uses H5Py first to create that test file and then read from it. So if I do a .NET run, then we run sort of, okay, since this is new, I did not commit that. Pip install H5Py. Gotta quickly install H5Pi. And let's try this again. Oh yeah, I forgot to commit that. I think there is there are also good comments here in the file, by the way. I forgot to commit this one change that I made, that he made at some point. This should work. So we are compiling. It's creating the, as you can see here, we are using H5Pi to create this, I've got 10 gigabyte or 1 gigabyte data set, and with 100 chunks. And right, so then we are flushing sort of caches. So we are not running against cache. So what he calls the sync benchmark, this is just sort of, sequentially reading all the data with a single thread. And now we are reading with 4 threads, if I remember correctly, using file-based, and then we are using memory mapped files. And the performance is actually pretty similar here between memory mapped files and the regular files. And you see that, okay, we are using 4 threads. This is actually almost linear speedup. So in terms of concurrent read performance, this is pretty good. Now, a caveat. The caveat is I actually had the pleasure of meeting the author of PureHDF at the European Hug event in September. And he told me that he found that, for example, let's say with local SSDs, it is very important to know how your SSD is actually attached to your bus, or what kind of interface your SSD uses, because depending on that interface, you may or may not get any speed up at all with multiple threads. So for example, if your SSD is SATA, has a SATA interface with the S being serial, you can run as many threads as you want. You're not going to see any speed up whatsoever, because all the accesses are serialized. However, if you have NVMe attached SSDs, then there is a good chance that you will see almost linear speed up within what your bus otherwise is capable of delivering. So in this case, it looks like they are probably NVMe attached. And so this is pretty much what I had, and I'd be happy to answer questions, although, let me show you one more thing, but you can sort of discover that for yourself. So I just created a Mickey Mouse Jupyter notebook here for C#, again, with this polyglot module. So it looks and feels exactly like an IPython, like a Jupyter notebook. So you have these markdown blocks, and then since this is C#, I can say console write. This is not Pascal. I can say console write line hello from C#, and here you can either sort of create a reference to the project, but he, the author of PureHDF, has a nugget. This is sort of like pip for Python. Nugget is this package management tool for .NET, and so you can use Jupyter Magic to install a Nugget package. So if I hit Control Enter, this downloads, and you can specify with this comma syntax here, you can specify a particular version if there are multiple Nugget packages available. And then, what we just did using PureHDF, we can create a new HDF5 file. And then in this case, okay, we just save it. So this just created here our foo.h5, and I can open that again in the H5 web extension And yeah, there's not much to see here. It's just a root group. Anyway, so I think this is a very exciting project, and I don't have time. It is certainly very interesting to look at how he organized the code and sort of, yeah, where does the serialization and deserialization happen, sort of what higher layers do exist in the code and so forth. I might come back to that the next time, or I actually have already another topic in mind, something very interesting I learned recently. But I might come back to this and delve a little deeper how he structured his code. But yeah, it is I think a remarkable achievement, and this is in part what this event is about. This clinic is to highlight the sort of the fascinating work that our users are doing. And yeah, I'll leave it there for now. Any questions?
Thank you, Gerd. Very informative.
Thanks. Mm-hmm. Well, all credits go to him. Yeah. Yeah.
Hey, Gerd, Alexander.
Yeah. Mm-hmm.
So my question is just to understanding. So this PureHDF5, what is the output when you read the data set in it? What it gives you as the output if I do a data set read or some kind of slicing of data set? What do I get back?
Oh, you would get a .NET array. Now I'm...
That's okay. I just want to
understand. Yeah. It just gives you a .NET array. So, for example, these literals that I had in my lame example here. So this is a two-dimensional .NET array initialized from this literal, and it would be a .NET array. Yeah, so it would be like a system in 32, whatever the... whoops. You guys can still hear me?
Yes.
Okay, good. Okay, sorry, I must have gotten briefly disconnected here. Sorry. Yeah, so it would be a .NET array. So unfortunately, there is not something like NumPy. I guess that's where your question is going. Is there something like NumPy in .NET? And I believe the answer is no, not to my knowledge.
All right, thanks.
Mm-hmm. Any other questions? No? Okay, and thanks a lot, and come back next time. I'm sure we will have something exciting to talk about.